This next unit focuses on stoichiometry, which is just a fancy word for figuring out how much of something you want based on what you have, or determining how much of something you can make based on what you have, just so that we don't have any extra or leftover reactants. Stoichiometry is the calculation of quantities in a chemical reaction, and those calculations are done by using information from a balanced equation, which means that all of those equations must fulfill the laws of conservation of matter. You can't perform stoichiometry calculations if you don't have a balanced equation. So with this in mind, when you see an equation, the first thing you need to do is go ahead and balance it by counting your atoms, making sure you have the same amount on the reactant side as the product side. N2 plus H2 yields NH3. Let's balance that. 1 N2, 1 nitrogen plus 2 hydrogen yields 2 NH3. So before you can do a problem, you have to look at your mole ratios. And the mole ratios are a comparison between the coefficients in that balanced equation. So when I'm talking about the coefficients, I'm talking about those numbers in front of each of the compounds. So in this case, 1 nitrogen would need 2 hydrogen in order to fully react. 1 nitrogen would produce 2 NH3 molecules. 2 hydrogen need 1 nitrogen to react. 2 hydrogen could produce 2 NH3 molecules. 2 NH3 molecules need 1 nitrogen to form, and then 2 NH3 molecules need 2 hydrogen molecules to form. So what we've just done is come up with all the possible combinations of those coefficients. And what ends up happening is you'll use these numbers as your conversion factors. So these mole ratios become your conversion factors. You have to look at your mole ratios, and the mole ratios are a comparison between the coefficients in that balanced equation. So when I'm talking about the coefficients, I'm talking about those numbers in front of each of the compounds. So in this case, 1 nitrogen would need 2 hydrogen in order to fully react. 1 nitrogen would produce 2 NH3 molecules. 2 hydrogen need 1 nitrogen to react. 2 hydrogen could produce 2 NH3 molecules. 2 NH3 molecules need 1 nitrogen to form, and then 2 NH3 molecules need 2 hydrogen molecules to form. So what we've just done is come up with all the possible combinations of those coefficients. And what ends up happening is you'll use these numbers as your conversion factors. So these mole ratios become your conversion factors. All right, let's look at another problem. This is a combustion reaction. C3H8 plus O2 yields CO2 plus H2O. I'll go ahead and try to balance it. We put a 2 in the front because it's combustion. 2 times 3 carbon, that's 6, so let's get 6 on the right. 2 times 8 is the same as 8 times 2. And now I'm going to go ahead and count my oxygen. 6 times 2 is 12. Plus 8 is 20. So I need 20 oxygen on the left-hand side, which means that's a 10. Now if I look at these coefficients, 2, 10, 6, and 8, those can all be reduced. So this becomes 1, 5, 3, and then 4. So let's write out all of our ratios, all of our possible combinations of reactant to reactant or reactant to product. 1C3H8 needs 5 oxygen to completely combust. 1C3H8 could produce 3 CO2. And 1C3H8 molecule could produce 4 water molecules. 5 oxygen needs 1 C3H8 to combust. 5 oxygen could produce 3 carbon dioxide. 5 oxygen could produce 4 water molecules. Let's look at the products. 3 carbon dioxide would need 1 C3H8. 3 carbon dioxide need 5 oxygen atoms. And then 3 carbon dioxide would form 4 water. And then finally, our last possible combination, 4 water need 1 C3H8. 4 water need 5 oxygen to form. And then 4 water would need 3 carbon dioxide. So those numbers in the ratio, those come from the coefficients in the balanced equation, and they represent the relative number of moles of reactants and products. So 1 mole of C3H8 would need 5 moles of oxygen in order to completely combust. If I didn't have those ratios, I would have leftover reactants and I wouldn't form, the full amount of products possible. So go ahead and try this next one on your own. Balance the chemical equation, identify the type of reaction, and then write all of the possible mole ratios for this reaction. There should be 12 possibilities.